In this video, I will introduce basic concepts behind testing of hypothesis. Let me narrate a simple scenario so that I can explain the concepts clearly. Assume that you are the operations manager of Oxford Cereals. You are in charge of the production process, hence you are responsible for monitoring the amount in each cereal box filled. Company specifications requires a mean weight of 368 grams per box. When the mean fill weight of the boxes differ from 368 grams, you are responsible for adjusting the process. Adjusting the process requires stopping the production temporarily, hence you do not want to make unnecessary adjustments. What decision-making method can be used to decide whether the filling process needs to be adjusted or not? There can be several procedures, but if you decide to use statistical inference procedures, you can proceed as follows. Select a sample of cereal boxes and find the sample average weight. If the sample average is significantly different from 368 grams, you may have to stop the production process and make necessary adjustments. How to decide whether this average is significantly different from 368 grams? You have to fix a boundary for this. For example, I can fix it as if it is less than 367 grams or more than 369 grams, I will adjust it. I fix this boundary arbitrarily. It cannot be permitted. There should be a procedure for that. This procedure is known as hypothesis testing. Hypothesis testing begins with a theory or claim about a process or parameter. Our initial hypothesis in this example is that process is working properly, so average fill is 368 grams and no corrective action is needed. This is called null hypothesis and is denoted by H0. Formally, I can define null hypothesis as the hypothesis that the analyst formulates and proceed to test. It is a claim or belief that he holds as true unless he has sufficient statistical evidence to conclude otherwise. In this example, the null hypothesis is that filling process is working properly. Therefore, mean fill is 368 grams. This can be stated as H0 mu equal to 368. Alternative hypothesis is the opposite of null hypothesis and is denoted by H1. In this example, this can be stated as H1 mu not equal to 368. Alternative hypothesis represents the conclusion reached by rejecting the null hypothesis. In many research situations, the alternative hypothesis serves as the hypothesis that is in the focus of the research. The null hypothesis is rejected when there is sufficient evidence from the sample data that it is false. If the null hypothesis is not rejected, you continue to believe that the process is working correctly and no corrective action is necessary. In the second circumstance, you have not proved the process is working correctly, but you have failed to prove that it is working incorrectly, and therefore you continue to believe, although unproven, the null hypothesis is true. Now the question is, how can we arrive at a decision? The decision-making process is not always clear-cut. Determining what is sufficiently above or what is sufficiently below is arbitrary without clear definitions. For this purpose, we use a particular statistic called test statistic and its sampling distribution. Using sampling distribution of the test statistic, the range of variation of the test statistic can be divided into two: critical region or rejection region and region of non-rejection. If the value of the test statistic calculated from the sample falls into critical region, you reject the null hypothesis. Otherwise, you do not reject it. Next, we will discuss some basic terms and definitions in connection with testing of hypothesis. We will start with one-tail and two-tail test. Null hypothesis usually takes the form no difference exists. This means that null hypothesis should be of the form H0 mu equal to 368. Alternative hypothesis may take several forms depending upon the objective of the researcher. Depending upon the form of alternative hypothesis, tests are classified as one-tail and two-tail test. If alternative hypothesis take the form H1 mu not equal to 368, the test is called two-tail test. If alternative hypothesis take the form mu greater than 368, the test is called right-tail test. Similarly, if alternative hypothesis takes the form mu less than 368, the test is called left-tail test. Combining right and left, in general, they are known as one-tail test. There is a reason for this. Mu not equal to 368 means mu can be either less than or more than 368. That is why it is called two-tail test, whereas mu greater than 368 leads to right tail. Similarly, mu less than 368 lead to left tail. I specified null hypothesis usually takes the form mu equal to 368. But if the alternative hypothesis is mu greater than 368, then certain authors specify null hypothesis as mu less than or equal to 368. Similarly, if alternative hypothesis is mu less than 368, certain authors specify null hypothesis as mu greater than or equal to 368. Next, we will discuss types of errors. The decision to reject or not to reject a null hypothesis is based on samples. Hence, there is every possibility of committing errors. Two types of errors are defined. Type 1 error, rejecting a true null hypothesis. Type 2 error, not rejecting a false null hypothesis. Usually, this can be expressed in the form of a matrix as follows. In test construction, type 1 error is considered as more serious. The maximum permissible level for probability of type 1 error is called significance level and is denoted by alpha. Actual probability of type 1 error calculated using a sample is called significance value or p-value of the test. Probability for type 2 error is denoted by beta and 1 minus beta is known as power of the test. Finally, the statistic based on which we decide to reject or not to reject a null hypothesis is known as test statistic. Based on these terms and definitions, we can define two types of test procedures. Procedure 1 is as follows. Divide the range of variation of the test statistic into two regions, acceptance region and rejection region, or critical region based on the significance level fixed. If the value of the test statistic calculated from the sample falls in critical region, we reject the null hypothesis, otherwise we do not reject it. The boundary of the critical region is called critical value. The critical value can be calculated using the sampling distribution of the test statistic and the significance level of the test. Procedure 2 is little more simple. Corresponding to the calculated value of the test statistic, we can find out the significance value using the sampling distribution. If the significance value is less than significance level, we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. Thus, we have the following 5-step procedure. Step 1, formulate the null and alternative hypothesis. Step 2, fix the significance level of the test. Step 3, choose an appropriate test procedure or test statistic. Step 4, using the test procedure, find the significance value of the test. Step 5. If the significance value is less than significance level, reject the null hypothesis. Otherwise, retain it. That's all about in this video, and in the next video, we will discuss various tests. Thank you. Thank you very much.